In this module, we're going to look at executive processes. And executive processes is a umbrella term for a whole lot of processes involved in regulating our thoughts and actions. So we already came across the term of executive when we talked about the working memory model. And in that model, we had the central executive in the middle. That system directed attention and information back and forth between the phonological loop and the visuospatial sketchpad and integrated that information in order to make some sort of decisions, produce some adaptive actions, get tasks done, and so forth. So the central executive in that model is a controller that also pulls information from long-term memory, coordinates tasks, integrates and uses information from the phonological loop and the visuospatial sketchpad, and then also allows you to focus on specific tasks, sequence them, switching attention back and forth between them, and so forth. Now, that's just within the working memory model, but executive processes are really omnipresent. We use those all the time, and they help us regulate our behaviors and be successful in the world. Now, what do we know about executive processes, and especially where are they located in the brain? Well, in the case of executive processes and executive control, there's really a landmark case that set the stage for any work on this later on, and that is the case of Phineas Gage. And Phineas Gage, you might know this story, but just in case, was a railroad foreman back in the day when they were building lots and lots of railroads. This involved a process by which they had to anchor these rails into the ground, and they did so by creating little holes and then detonating dynamite in order to be able to sink these tracks deep into the ground so that they wouldn't move. Phineas Gage was a foreman of that production, meaning he was in charge of a lot of people building these roads, very well respected, hardworking guy, until in 1848 he had a tamping iron accident where what happened was essentially that there's a certain procedure and a certain order of steps you had to go through in order to create a hole in a safe manner. And part of that involved putting dynamite in the hole and then detonating it. Now, on this particular day, Phineas Gage was creating such a hole and actually mixed up the order so that he had put dynamite in a hole and then started tamping it, which you weren't supposed to do until after the dynamite had detonated. What happened was that the tamping iron actually then detonated, and because Phineas Gage was hanging right over the hole, the iron actually shot right through the front of his brain and created a very sizable gap. It entered through his right below his eye, came out on the top of his head, and blew right through his frontal lobe. And this is his actual skull, so you can get some idea of where this iron exited, and it entered actually right here, right below the right eye. Now, interestingly enough, Gage actually supposedly barely lost consciousness or conscience and got up fairly quickly, didn't seem to be experiencing much pain, by most measures appeared to be okay, until in the next couple of days it started to look like Gage had in fact changed in pretty substantial ways. He was highly disorganized, he had become nasty, he wasn't friendly to people anymore, couldn't really sequence his actions successfully, couldn't really get anything done, and subsequently was fired from his job because of the problems he was actually experiencing from this accident. So from this case, we actually learn a lot of things about the frontal lobes and about executive control. So much so that it gave rise to what is now called the frontal executive hypothesis. And that hypothesis states that every executive process in the brain is highly mediated by the frontal cortex. So that very frontal part of our brain really helps with regulating our behaviors in all sorts of ways. And we'll see in what kinds of ways this is throughout this module. It's strongly related to the central executive in the working memory module. And what you'll see here too is that these executive functions are really a class on their own, meaning you can actually be okay in many different ways, except if you have damage to that lobe, then you actually experience a whole host of problems. So one example where executive processes are typically really the first to go is, for example, in Alzheimer's disease, when people start having damage to specific areas in the brain. And in that case, specifically, the frontal lobe is impacted pretty heavily. And the hippocampus is another formation that gets impacted by Alzheimer's eventually as well. So we already saw that helps with forming new memories. Of course, that's part of the problem with Alzheimer's. But interestingly enough, the damage to the frontal lobe is originally typically more severe. And what that gives rise to is that when people have onset of Alzheimer's, their memory at first may seem okay, but then they'll start kind of experiencing trouble with regulating their actions. They will start doing things like getting into their car while they forgot their car keys, leaving the stove on after they cook, and typically they become somewhat nasty as well in those early stages. And part of that might be because they lose the ability to regulate their emotions, and yet they're also still clearly aware enough to know that something is not going quite right, and you can imagine that that must be pretty scary, frustrating, and so forth. So that's because in Alzheimer's, again, there's plaques that form, big protein complexes that actually start blocking the proper functioning of the brain, and that is one of the onset symptoms of Alzheimer's disease. Now, children with learning disabilities also often show issues with executive functioning, and oftentimes that too has been linked to the development of the frontal lobe. Now, if we look at the frontal lobe, again, the brain is a vast network of different neighborhoods that all are interconnected and so forth. But if we look at the frontal lobe, and specifically the prefrontal cortex, there's two parts that play a very, very substantial role. And those two parts are the dorsolateral prefrontal cortex and the ventrolateral prefrontal cortex. Now, those two different areas will keep coming back up, but they do slightly different things. They're all involved in executive control, but the dorsolateral prefrontal cortex is specifically involved in executing motor plans, sequencing things in the right order. So when you tie your shoelaces, you first put your shoes on and then you tie them, rather than first tying them and then putting the shoes on. And part of that area is also Broca's area, which is involved in speech production. So there again, it's very important that speech gets sequenced in the right ways so that you get the words in the right order. That too, the dorsolateral prefrontal cortex plays a major role in. The ventrolateral prefrontal cortex is very much related to emotionally appropriate responding. So in other words, not immediately cursing somebody out when something goes wrong, making sure you read social cues and so forth. It's also involved in assessing risks associated with certain decisions and fear and decision making in general. So that will come back up as well. Now, in this module, we're going to talk about several different executive processes, and I'm going to tackle these one at a time. The ones I'll talk about are executive attention, task switching, response inhibition, and then monitoring.